All right, guys. So we're going to start with our last section of the notes. We're talking about the series of geometric sequences, which is just the sum of those geometric sequences. There are two types. There are finite and there are infinite. And so we're going to finish up on these really exciting times. Okay, so the sum, S of n, of the first n terms of a geometric sequence is S of n equals a sub 1 times 1 minus r to the n over 1 minus r. All right, be careful there. That is an exponent, which means that you'll even have to be careful in your calculator too. Okay, so we're finding the first, the sum of the first 18 terms. It's given to us that it's a geometric sequence, or a geometric series, and it stops it keeps going, but we only want the first 18, so that's how we know that it's finite. All right, so looking at this equation right here, I need three things. I need a sub 1, I need r, and I need n. So I need a sub 1, r, and n. A sub 1 should be easy to find. Dang, that's blurry. Come on, you can do it. Okay, hopefully you can see that a little bit better. Okay, so we have a sub 1, which is our first term, 2. We have r, which is going to be our common ratio. So the way that we find that is -8 divided by 2, which is -4. And then our n is going to be the number of repetitions of that, so 18. And we just plug that into our equation. So we have S of 18 equals 1 minus -4 to the n all over 1 minus r. Okay, so we're going to take special care when we plug this in. I'm going to use Desmos because I think it's the easiest way, but if you're using your calculator, make sure you type that in correctly. So we have Desmos. So we have 1 minus -4, parentheses around that, to the 18th, all over 1 minus r. Nope, something's not right in what I typed. Oh, we forgot to multiply by a sub 1 right here. So let me go back to my equation. Okay, so right here, we're supposed to multiply by a sub 1, and I forgot it. So put a 2 on the outside there. So then when we type it in, it should be 2 times that. Here we go. Okay, that looks a lot better. So we have -2.75 times 10 to the 10th as our answer there. So -2.75 times 10 to the 10th. Okay. So we haven't quite talked about it yet, but we are going to start talking about infinite geometric series. And what we're going to know is that this right here, if we were to take the whole infinite series, we could find it because we have a fraction there. But we'll talk about that in just a second. So let's go ahead and figure out what these values are. So we have a sub 1, r, and n. Looking at this equation right here, it's in our geometric series form. If you remember back, this value right here, that 3, is going to be our a sub 1. Our R is that 2/3 right there. And N is going to be this value right here, 8. So we'll plug that into our equation. So we have S of 8 equals A sub 1 times 1 minus R to the N over 1 minus R. All right, and then let's go ahead and plug that into, oh, that's not the right value for R. This is R, 2/3. 1 minus 2/3 is R. Sorry about that. Because our R gets plugged in there, and R is 2/3. So plug that into Desmos. We've got 3 times 1 minus R to the 8th divided by 1 minus 2/3. If we round that to the nearest hundredth, we get 8.65 as that sum of the first 8 digits. Okay, now if I were you, I'd pause here, try and do this problem on your own, but I'm going to keep running along here. So I'm going to rewrite our equation so we have it. Oh, my computer's going to die. Let's see if we can get through that in this time. So here's our, oh, it's already right here. Here's our equation. So before we even start reading it, I'm just going to write out to the side A1, R, and N so that I can run through what each of those are as we're reading through the problem. Right, so union contract specifies that each worker will receive a 5% pay increase. Okay, so that's going to be our R value, our rate. And so we know that 5% as a fraction, as a decimal is 0.05, but that's not all that it's going up. It's actually, that's not the whole rate. It's just going up by that amount. So we have to add 1 to that. So 1.05 is our rate. So we have to be careful with those percentages. Gosh, this is so hard to see. Okay, then let me move this. Okay, it says one worker is paid $20,000 in the first year. So that $20,000 is going to be the initial amount. It says, what is this person's lifetime total salary over a 30-year period? So it's 30 years. We want to know what the total is over 30 years. So his salary the first year was $20,000. His salary the second year was how much? And then you add all those together. So we're going to go ahead and add all these values together by using our equation. So we've got S of 30 equals 20,000 times 1 minus R to the N all over 1 minus R. So we'll plug that value in. I don't understand why I keep getting these notifications. My computer slows down significantly when it's going to die. So 20,000 times 1 minus 1.05 to the 30th. We don't have to have that 1.05 in parentheses because it's not negative. And then we divide by 1 minus 1.05. You could simplify that before if you'd like to. But what you end up with is, beautiful. Okay, what we end up with is $1,328,776.95. So that is how much money this union contract worker makes over his lifetime. Now, does he ever see that $1 million altogether? No, because it all goes to taxes and rent or mortgage, whatever it is that he's doing. So, okay. So that is how we find a finite geometric series. Let's go ahead, flip to the next page. Actually, the next page, if you look, it has this LKJ. I didn't label that correctly. I meant to go back later and I forgot. Go ahead and skip that page. We're actually, those are just practice problems. So we're going to skip that and go on to our infinite geometric series page.